Here we are at the final video of this section, using system.zip and publish-subscribe mechanism. In the previous video, we've learned how to use system.net encodings. In this video, we'll see a simple zipper-unzipper tool implemented using the tzip file class declared in the system.zip.pas unit. Historically, Delphi contains the tz compression stream and the tz decompression stream to respectively compress and decompress streams of bytes using the zlib format. These classes are quite useful, but are quite low-level, being simply a stream compressor. In this video, we'll use a high-level class to compress and decompress folders and files. It is quite limited in terms of possibilities, but is very simple to use. Just keep in mind that this class is very specialized, so if you need some compression library to work with network protocols or on-the-fly compression, decompression, don't use this. But if you need a no-brain solution to compress something, this is the way. Open the project at section 3/video4/zip-unzip/zip-unzip.dproj and run it. The GUI is quite simple. Click on the button and see the results. This little program is a showcase for the tzip file class. In the folder, there's also a test folder called folder2zip with 4 files inside. These files are zipped, inspected, and unzipped by the code under the button. Let's see it. Yes, it is quite simple. Obviously, if you don't need to inspect the zip content, all this program becomes as follows. I told you, it's not so flexible, but it is really simple to use. So, if you need to decompress an update file for your program, and you need only decompression, you can use the tzip file class and don't use external components anymore. There are a lot of compressing libraries available for Delphi, but before including a third-party dependency in your project, it's better to check whether the RTL has something usable for our job. For example, sometimes we need to compress our data, either to reduce network traffic when transmitting or just to save space in storage media. As explained in the previous sections, Delphi wraps the zlib library into 2 tstream descendant classes, tz compression stream and tz decompression stream. To use them, you need to include the system.zlib.pas unit in your use list. In the project folder, there is a bonus project that shows you how to compress and decompress generic streams, which can be file stream, a memory stream, or anything that can be wrapped as a stream. Here's the relevant code. The publish-subscribe pattern, also known as observer, is a very popular design pattern. It comes under a lot of different names, but the final scope is always the same. Alert someone when something interesting happens to it. In this video, we'll see some utilization of the tMessageManager class, the publish-subscribe mechanism implemented in the system.messaging.pas unit. What exactly does the cross-platform tMessengerManager class do? Put simply, it allows you to listen for events and assign actions to run when those events occur. Just like in VCL or FireMonkey, you know about mouse and keyboard events that occur on certain user interactions. These are very similar, except that we can emit events or send messages on our own when we want to, and not necessarily based on user interaction or other mechanisms inside other components. The tMessageManager is based on the publish-subscribe model, because we can subscribe to a particular type of message and then publish them. The other important question is this. Why would you use the event model? You already know that in Delphi, the event model allows to decouple the built-in UI code from the business code. But another benefit to events is that they are a very loose way of coupling parts of your code together. An event can be omitted, but if no code is listening for it, that's okay. It will just be passed unnoticed. This means removing listeners never results in compile or runtime errors. tMessageManager is the class in charge of the application's message handling, and it manages message dispatching. Its default manager property returns an object that acts as an application-wide notification center and is widely used in mobile development to listen for system-generated events. You can call tMessageManager.defaultManager to access the singleton instance of tMessageManager. However, in many cases, you'll be happy to know that it is possible to create many instances of tMessageManager. Once you have an instance of tMessageManager, you can call tMessageManager.subscribeToMessage to subscribe message handling methods to specific types of message. The events hooked to the subscription may be methods of an object or anonymous methods. After you subscribe a method to a type of message, every time there's a call to tMessageManager.sendMessage with a message of the target type, the subscribed methods are called. A simple interaction with one publisher and two subscribers is implemented in this code. With this in mind, let's say that our customers ask for an application with some floating tool window showing information about what's happening in the main form. For the sake of simplicity, let's say the secondary forms must show the text entered in the main form memo. A first naive approach may imply a deep connection between the first form and all the secondary form instances, so that when the memo change, the main form knows all the secondary forms available and updates the content of the T-labels. This approach is really wrong. In such a way, we are coupling the main form with all other forms, and it's also difficult to maintain. Using the tMessageManager, instead, all the forms are decoupled from the main form, the code is simple to maintain, and new features can be simply added. Let's see the logic schema. The Message Manager nicely decouples the component of our system. Open the project named Section 3/video5/messaging.dproj. The main form is quite simple. There's a memo where we'll write text and a button that will open a secondary form. The code under these two controls is highlighted here. Here, the btn OpenClick event handler simply creates and shows a new tsecondary form instance. The mem text change event handler sends a message of the type tStringMessage, a type defined in the myMessageManager unit, to the private tMessageManager instance. Where is this instance created? Open the myMessageManager.u.pas unit, and these are the code. With this simple unit, we can simply write the code. To subscribe to this specialized message manager to send messages. Simple and powerful. Let's see the consumer of these messages in the tsecondary form code. So this highlighted code for the tsecondary form. Now run the project. Click 4 times on the main forms button and rearrange the windows so that you can see all of them. Write some text in the memo and you should see something similar to this. The message is delivered to all the subscribers. Messaging is a really large topic. The same concepts we saw in this video can be applied also to distributed systems using Enterprise Message Bus. For that, you can have a look at this link. Also within our program, messaging is a great way to decouple our classes and to make software easier to maintain and improve. Another real-world use case for object types is within the boundaries of a class. Remember that publishing a message is a synchronous process. Your call to send message will not return until each subscriber's message listener code is run in turn, so your publisher will take longer for the send message call to return. About multi-threading, consider that tMessageManager is not usable in a multi-threading environment as is. If you want to create a more complex multi-threaded messaging system, you have to manually handle the synchronization between threads. Great! We've successfully learned how to use system.zip and publish subscribe mechanism. In this section, we first learned how to check strings with regular expressions, and then we moved on to learn how to use native HTTPS client libraries for RESTful services. We've also learned how to use system.net encodings, and finally learned how to use system.zip and publish subscribe mechanism. In the next section, we'll learn about cross-platform with FireMonkey.